When we talk about proofs using segments, it's going to be similar to what we just did with our algebraic proofs. So that was a soft introduction to this. They're going to give you some terms new terms and new postulates and new theorems and things that you're going to use, but you're going to have different definitions that we're about to introduce that apply to not just to segments, but it's where it's introduced, but where it applies some of them just to segments like midpoint, some of them like we've done where you can add up the two pieces, but now they're going to give a name to some of this so that when you start using proofs, you can use the names of what you have. Just like any proof, you have to identify the premise or the given information. So with any proof, you need to start out by saying, what do they tell me? Sometimes when you have a segment proof, so with algebraic proofs, they basically just give you a function, whatever it was, and you were to solve for it. But with segment proofs, sometimes they'll give you a picture. And so you can use anything that they've given you in the picture as long as it's identified, meaning you can assume something. But if they give you something that tells you it's congruent, like congruent marks, then you can take that as given information. So if it is marked on the picture that they've given you, you can use that as given information. Or if they tell you this equals this, or this is congruent to this, you can use that as given information. So you need to look at everything that they have set out, written out, and you need to look at the picture itself to see what they have given you, what information you have. Then you need to identify the conclusion. So typically they will say, given this, prove this. And so you need to make sure that you always know what you're trying to prove. That's very important. Just like when you're doing a word problem, it's important to know what you're solving for. Given a proof, you need to figure out what you're trying to prove. If they did not give you a sketch, you can write a sketch. So like in the one they just gave us, they said A, B, and C, and they could have just said AB equals this, BC equals this, and they maybe didn't give you a line segment. You can draw a line segment if they didn't give you one. Consider anything you already know. So anything in the given that maybe has a definition, like for example, the one we just did, A, B, C, that told us it was between. Between actually has a definition. And so if they give you a word in the initial part that has a definition that helps you move on, you're probably going to move on using that definition. Sometimes you want to see what you're trying to prove and go back and say, well, what do I need to prove this? And that will help you move forward in one of these proofs. All right, so let's look at your handout here. Let's look at this handout. All right. Oh, we don't want that. All right, so we have all of this information here at the top. Just to quickly go over the information at the top, we've gone over properties of equality. So this is just a reminder of what that is. Addition, subtraction, multiplication, division, distribution, substitution, reflexive, symmetric, and transitive. And then we have properties of congruence, all right? So let's look at these properties of congruence. The first thing there in your handout, properties of congruence that you need to fill out, all right? So first, I want to point out, make sure you know your congruent symbol. Your congruent symbol is the equal with a little squiggle above it. The first thing is the reflexive property. We talked about the reflexive property with equality. Any line segment is congruent to itself. That seems intuitive. It seems like you should know that, but you sometimes have to state that. Sometimes when you have two pieces that overlap, you'll have to tell me that it equals itself so that you can use it in both sides. Symmetric property. All right. This is the same as equality. If they are telling you to prove that AB is congruent to CD, and at the end of it you got CD is congruent to AB, you do have to do another step to do it exactly what you're trying to prove. And this is the symmetric property that lets you just flip-flop on either side of it. The last one on this group right here is the transitive property. We've talked about transitive, not just in the law of syllogism, but also in equality. It also works for congruence. If line segment AB is congruent to line segment CD, and line segment CD is congruent to line segment EF, then line segment AB is congruent to EF. Now, I want to make sure you understand that transitive works the same. It's just now talking about congruence. Congruence is talking about the actual figure itself, not the length of the figure. The length of the figure is a number, and you would use equals for the number. If they're talking about the line segment, meaning they have this notation above it, They are talking about the physical segment itself, and you would use congruence here. All right, let's look at the definitions here. The definitions. Definition of congruence. Now, very often they will tell you congruent, and then you're going to have to start adding and subtracting things. You cannot add and subtract congruence. The properties of equality, addition and subtraction, only work for equality. They do not work for congruence, okay? And so they give you this definition here, and all this does is it can change. What you're doing is you're changing it from congruence to equality so that you can use the addition, subtraction, multiplication, and division, all right? And very often you'll do all that, and at the very end you might have to convert it back to congruence because that's what they're trying to prove, all right? So the definition of congruence is just telling you if the segment is congruent, then the measures of the segments are equal, and vice versa. If the measures are equal, the segments are congruent. The reason you use this is you cannot add and subtract segments. You can add and subtract segment measurements. So it has to be in equals before you start adding and subtracting. The next definition is midpoint. The midpoint of a segment divides the segment into two equal or two congruent parts. If M is the midpoint of AB, then the measure of AM equals MB. So it's just telling you it's dividing it into two congruent parts or two equal distance parts. And then they've given us a postulate. So at the very bottom of the page, you have a postulate. This is your segment addition postulate. This is what we used in the last chapter. If you have a segment and there's a point in between the two endpoints, then the two pieces add up to the whole, all right? And so there are going to be times when they give you this picture and you're going to say, hey, AB plus BC equals AC. And your reason for being able to do that is going to be the segment addition postulate. So the reason you can do that is because of the segment addition postulate. All right, let's go over these. Number one, if PQ equals PQ, then PQ is congruent to PQ. What tells me that? Definition of congruence. Definition of congruence. All right. Number two, if K is between J and L, then JK plus KL equals JL. Yes, that's segment addition postulate. Segment addition postulate. Line segment EF is congruent to line segment EF. Reflexive property. If RS equals TU, then RS plus XY equals TU plus XY. You can add XY to both sides of an equation. What tells you you can add something to both sides of an equation? Yeah, addition property. Addition property of equality. If AB equals DE, then DE equals AB. Yeah, that is my symmetric property. You can flip-flop across equals or congruence. If Y is the midpoint of XZ, then XY equals YZ. Definition of midpoint. Definition of midpoint. All right. If FG is congruent to HI and HI is congruent to JK, then FG is congruent to JK. That's transitive property. Transitive property. Remember, it works for equality and for congruence. If AB plus CD equals EF plus CD, then AB equals EF. What did they do to both sides? Subtraction property tells you can subtract CD from both sides. As long as it doesn't have the segment above it, you can do addition or subtraction. That just means the length of it. They can subtract the length from both sides. If PQ plus RS equals TV and RS equals WX, then PQ plus WX equals TV. What did they do? They actually substituted here, right? Substitution. All right, so look at this one. We have this little equation, PQ plus RS equals TV. They gave you something that equals RS, and then they substituted that in for RS in this equation. So this is substitution. If LP equals PN and LP and N are collinear, then P is the midpoint of LN. LP equals PN, and they had to tell you they were on the same line. So from LP to PN, what was that? Definition of midpoint again. Remember, midpoint tells you that the two pieces equal each other. They had to tell you they were collinear because it could have been a triangle. So if they weren't collinear, you could have had two line segments that were not a segment in and of themselves. They could have turned at that point. What about 11? If segment UV is congruent to UV, then the length of segment UV equals UV. This is definition of congruence. They didn't just say that UV equals itself or that it was congruent to itself. They actually converted. For anytime you go from congruence to equality or equality to congruence, it is definition of congruence. And then the last one, CD plus DE equals CE. Then CD equals CE minus DE. What did they do to both sides? They subtracted. So this is subtraction property of equality. Subtraction property of equality. So today we're just doing concentrating on proofs where they kind of give you the steps a little bit and then you just tell me why. And then tomorrow we're going to move into where you actually do the whole thing. You do all the steps and all the reasons. So on your handout, you have several proofs here. You're going to need this today and tomorrow. The first one we're going to do is number 1. This is how your proofs will typically be set up. Given E is the midpoint of DF, prove that 2DE equals DF, all right? I want to point out that they started out giving you a line segment, and then they went to the line measurements, okay? So, it will look like this, and they gave you a picture. This given will always be your first step. All right, and sometimes they'll give you several things and maybe you break that given up into multiple steps. But you'll notice this exact verbiage here is your first statement. E is the midpoint of DF, E is the midpoint of DF. And so when that is the case, what is your reason? Why can they tell you that? Because it was given. And so that's how your proofs will always start out. They give you something, you're going to write it down as your first statement, and you're going to tell me the reason you can give me that is because they gave it to you. And so your reason here is just going to be given. So your reason here is given. All right? With something like this, then you want to look at the words they gave you or the information they gave you. They gave you this term midpoint. So anytime they give you a term like midpoint, you are likely going to start with the given statement and then move to something that has to do with the word midpoint. All right? So look at the next statement they gave us. They said the measure of DE equals the measure of EF. So they told me this measure equals this measure. All right? Why can they tell me that? Right. It comes back to this statement right here. The definition of midpoint. The reason they can go straight from that second statement to the second statement is the definition of midpoint says they can do that. And so my next reasoning here is just going to be the definition of midpoint. So for these type of proofs where they give you the steps, you are doing exactly what you did on the page we just handed out. You are looking to see what they did and why they can do it. All right? So let's look at the next one. From statement 2 to statement 3, what did they do? They added DE to both sides, right? They added a DE here and they added a DE here. Why would they do that? First of all, let's talk about why they would do that. We'll go back to what we're trying to prove. We're trying to prove that 2 DEs, 2 of these equal the whole segment. Well, logically, it makes sense if DE and EF are the same, then 2 times DE would equal the whole line as well. But you have to step-by-step prove it. So the reason they added DE to both sides and not EF to both sides is because eventually they want to get to 2 DEs on one side. All right, so that's what they're doing. What property actually tells you you can add the same things to both sides of an equation? What property tells you that? The addition property of equality. And so that's why they can actually do it, is the addition property. The reason they chose that one is because of what they're trying to prove. So the addition property of equality tells you they can do that. Now, what did they do from step 3 to 4? All they did was add DE and DE. What is that? Yeah, it's combining like terms or simplifying. So all they did was simplify here. All they did was simplify. Now, down here, they have jumped to tell me that DE plus EF equals DF. What rule tells you that two pieces of a segment added up equals the whole segment? Right, so if you go back to your handout, this is the segment addition property, or postulate rather. So this is the segment addition postulate. Segment addition postulate says that you can do each piece. They want to be able to say that 2DE equals DF, okay? Right now they have 2DE equals DE plus EF. We have to define what DE plus EF is. So all they did on this step is say, well, what is DE plus EF?
So that's not like really a step.
It's not a from 4 to 5. It is an assistant so that you can do a transitive property.
Wait, so that you...
Nowhere to this point have you told me that DE plus EF equals DF. You've never told me that. So you could not substitute this in or do a transitive property here to tell me that 2DE equals DF. So here they're just looking at this and saying, what am I trying to prove? I've got my 2DE, right? That's part of my proof, yes? I'm trying to prove that it equals DF. Well, right now I only have that it equals DE plus EF, all right? And so now you have to tell me what this side equals. Well, DE plus EF equals DF. The two parts equal the whole. Okay, and now that I have that, I can go straight from the 2DE all the way to the DF. What property tells me if A equals B and B equals A, then A equals C? What property tells me that? Transitive. Okay, so what they did is here they were like, wait a second, I haven't proved it yet. Okay, I have not proved what I'm trying to prove. I've only gotten to this point. So now what does this equal? Well, this guy equals the whole thing, which is what I'm actually trying to prove. So I need to put this step in here, hey, segment addition, so that I can say, well, if A equals B and B equals C, then A equals C. That's transitive property. And so transitive property is what I'm going to go to next. Transitive property tells me I can go from the first to the last. That's the law of syllogism that we did with reasoning, all right? And now I have actually proven what they wanted me to prove. I've proven that 2 of my line segments DE will equal the line segment DF when I add up their measurements. All right, let's look at this one. Given the segment KL is congruent to LN and segment LM is congruent to LN, prove that L is the midpoint of KM. All right, and they've given you a picture here. So the first statement that they gave us was segment KL is congruent to LN and segment LM is congruent to LM. Why can they tell me that? Given. So, yes, given is always your first step. And sometimes you'll use it when we get to more difficult ones, you'll use it, so you'll break it out sometimes, or sometimes you'll list it at the top. It's just always how you do it. But your first reason is always going to be one of your given statements. All right, so from 1 to 2, all they did was change it from segments and congruence to distances and equality. What tells you that you can go from congruence to equality? Definition of congruence. Anytime you go the same exact statement and they just changed it from congruence to equality or equality to congruence, it is definition of congruence. All right, so they have KL equals LN, and then they have LM equals LN. All right, what property tells me I can do that? Yeah, you can use transitive, and I would actually also take substitution here. All right, so I would take either because of how it is. you can either say, well, they substituted LN for LM, right? Or you can say KL to LN, LN to LM, transitive. So for this one, I would take either property, transitive or substitution. You can't always just combine those. Sometimes you can't use substitution, or sometimes it has to be substitution. But in this case, I would take either substitution or transitive. All right, last one. We have that KL equals LM. How can they then tell me that L is the midpoint of it? Definition of midpoint. Once you have that those two pieces equal each other, you know by definition of midpoint. Definition of midpoint. All right. So, given K is the midpoint of segment JL, M is the midpoint of segment LN. They've also told me that JK equals MN. They want us to prove that that segment KL is congruent to segment LM. So a lot of times when I have something like this, because it's a handout, this is where if you use colored pencils or highlighters, you may want to start paying attention to what you have. They've told me that K is the midpoint of this line segment and M is the midpoint of that line segment. And then they have told me inequality. So they've told me that JK equals LM. So they've told me that JK here, this one equals MN here. All right. And so what they want is they want us to prove that KL, this guy, is congruent to LM. All right. And so some key things you want to pay attention to in your given. You've been given the word midpoint. So somewhere in this, I would guess we're going to use definition of midpoint. Okay. So when they hand you a keyword, you're likely going to use a definition or a postulate that comes from that keyword. All right. With segments, you are, in this one, not necessarily, but a lot of them you're going to use segment addition postulate. And you'll also notice that they gave you an equality in your given, but your final proof is a congruence. So somewhere in here, we're probably going to use definition of congruence as well. And so look for key pointers here. I also want to point out that they did put two of their givens on one line, and they're going to wait and give you the other one later. That's a technique sometimes for logic reasons. You could list all of your givens at the front if you want to. Sometimes it makes sense to list what you need and to use that. And then down here, I need to go back and say, okay, this is equal, and now I can go from here. And so sometimes you'll break up your givens. Sometimes you can list it all at the front. It's all in how you want to do your proof. Just don't forget when they give you so many givens to go back and use all of it. Somewhere along the way, you need to use all of your givens. All right. So for the first statement, always easiest. Why can I say that K is the midpoint of segment JL and M is the midpoint of LN?
Given.
Yeah, that was given. All right. Now, they have now said that JK equals KL and that LM equals MN. Based off of my given, why can I say that? Those two segments equal each other. These two segments equal each other. Why can I say that? Definition of a midpoint here. So anytime you have midpoint, you probably want to tell me which two segments equal each other because of that midpoint, and you can tell me that by definition of midpoint. So definition of midpoint here. All right. Now they have that JK equals MN. Why do they know that? Yes, it was given. At the very beginning, they told us that. And so they just happened to break it up because they want to use it right here. So this statement was also given. It was given right here. All right, now they have said that MN equals KL and LM equals MN. All right, so let's look at this. We have JK equals MN. And they are trying to tell us what two pieces. MN equals KL. All right, MN equals KL. Well, why can they say that? We have KL up here equal to JK. right? JK equals KL. That's what we said. Now they're saying that MN equals KL. And then we have that LM equals MN. That's the same. But what did they do here? They replaced MN with JK, right? They replaced these, right? I'm hearing it. Why can you do that? Substitution. All they did was they replaced this little piece here with what we know it equals. This is substitution. So all they did was they took line 2 and they substituted. Substitution. All right, so we always have to look at what we're trying to move towards. We're trying to move that KL is congruent to LM. All right, and so right here we have that MN equals KL, LM equals MN. And now they're going to go, so here's what they've done. They went from LM equals MN, MN equals KL, and now LM equals KL. There's two different properties you could use here, which are what? A equals B and B equals C, so A equals C. What did they use here? They used transitive. And I would actually take substitution here as well because they just went LM and they replaced it with K. So I would take either transitive or substitution here. Transitive or substitution. All right. Now, are we trying to prove that LM is congruent to KL or that KL is congruent to LM? Right, and we have it in a different order right now. All right, we have it in a little bit different order. We have it LM equals KL. So all they did was flip-flop the order. What tells me I can flip-flop the order here? Symmetric property. All they did was change the order. So that's symmetric. And on the last line, all they did was go from equality to congruence. What tells me I can go from equality to congruence? Definition of congruence. All right.